Thanks, Alan, and thanks everybody. Great to be here. And shout out to the AV crew. This is a high level of production quality for a meetup, and that is extremely impressive. So yeah, I'm going to talk to you today about escaping AI proof of concept, Purgatory techniques for enterprise AI engineers. This could also be called what's working for us and our customers at Writer that we think other developers would benefit from. So I know like Nathan's talk is going to be a lot more research pilled, as he called it. Mine's going to be more focused on AI engineers and builders and that kind of thing. So in 2024, this year, we've seen a real loss of faith. We saw a lot of hot headlines around AI hype dying and the generative AI winter and why AI projects are failing. And there's some good reason for that, actually. Uh, this is some data from Bain Capital that was put together at a chart, and it's comparing two periods of time, October 2023 to February 2024, and it's looking at enterprise adoption. And the light red is development projects and the dark is production projects. And you can see that across all of these different verticals, the number of development projects keeps going up, but the number of production projects keeps going down from in that 6-month period. So we're seeing a lot of skepticism around enterprise use cases for AI. And what we've seen just with companies that we're working with is that AI can really become a gravity well for enterprises. They start with really good intentions, they build a lot of proofs of concept, and then they get trapped and can't really get anything to production at scale. And that usually is due to three main reasons: low accuracy, low efficiency, and low adoption. So how do we escape? How do we get from proof of concept to production? How do we actually achieve escape velocity to get into production? So I'm Julien. I'm the Director of Developer Relations at Writer. I basically run our DevRel and our developer experience, our docs, our SDKs, all of that to make sure that our customers are able to build on our platform successfully. So how do we achieve escape velocity? Well, what's interesting about these headlines this year is that at Writer, we're actually seeing the opposite. So we're a full stack enterprise AI platform. We build our own models, we build our own approach to RAG, and we have a whole suite of developer tools on top of that. But at Writer, what we're seeing with our customers is actually quality, efficiency, and adoption. And these aren't kind of small little companies either. These are big Fortune 500, Global 2000 kind of companies like Dropbox and Kenvue and Franklin Templeton and Salesforce and people like that. So what I wanted to do was share in this talk some kind of package up some lessons that we've learned over the course of these last several years, what we're seeing work for customers. So in physics, there's this concept of delta V, which is like the velocity, the change in velocity needed to actually like get out of orbit and into flight. And so I've kind of put together this little paradigm of enterprise AI delta V and the kind of three components to that: scope, accuracy, and rapid UI and UX. So let's start with component one, which is reconciling AI engineering scope. So we're in this situation where we have this paradox right now where on the one hand, AI engineering is requiring lots of infrastructure and resources. But on the other hand, we're seeing all this immediate ROI coming from these really scoped, focused tasks at scale. And that is difficult to reconcile. So when you look at kind of the typical adoption path of a big enterprise company wanting to build with generative AI, there's a very common pattern that happens. The first is that they immediately sort of reach for off-the-shelf solutions that have specific use. So maybe they need some tools for marketing or copywriting, or they need something for customer experience, and they start purchasing all these little SaaS platforms, products, and they start to add up over time. And there's nothing wrong with those things, but what ends up happening is they're slowly adding to their security risks, their management overhead over time, and they start to realize that that's not a sustainable practice. And then what happens is they realize that they're going to run into issues where they need more customizability, more bespoke solutions. They find that for things that are more simple, have fewer accuracy requirements, they can reach for those off-the-shelf solutions. But when they have much more complex situations, then there's some sort of development required. Very common use case that we see all the time. So then they go down the road of, okay, how do we build it ourselves? So they start investing in resources and planning and trying to figure out infrastructure across orchestration and ML ops and build it. What models do we use and what's our app platform? And down and down this road they go. And then get stuck in this what we call a gravity well, where they can't actually get anything into production, but they've invested millions and millions of dollars. So what we see then is, because they've got all this sunk cost, they then need to solve every problem at the company and build some massive platform using AI. And so they start kind of boiling the ocean, trying to solve all the company's problems. So first tip that I have that we've seen work at Ryder with our customers is to think in terms of microservices instead of monoliths. So rather than trying to build like kind of one giant application that works on everything, what we're seeing work really well for customers is that they have these like scoped, focused solutions that solve a particular problem, and then they can kind of expand that out. So if they're in, they're in some sort of product, IT product or something like that, then maybe they have an application or a service that generates product description pages, and one that is formatting user stories or release notes or things like that. And thinking in terms of that level of like scoped, focused solution. The way we do this at Ryder is we sort of have this platform as a service. So we've got our like LLMs and RAG and AI guardrails, and then like our inference and infrastructure layer. And all of that is abstracted away from the customer. And then we have part of the platform that's like pre-built applications. And then part of it is this like development platform. And we call this like the full stack approach. And you could steal this pattern from us, where basically the idea would be that you could provide some pre-built applications for different teams at the company, but then enable some self-service options where they could build some of these like microservices that you could string together and access in different locations. We're getting into sort of like the agentic era now. And so we've sort of reformatted this full stack approach. And so this is another way that you could look at it. By the way, these are like marketing slides. I'm not really trying to sell you on Ryder at all. I really just want to share these lessons with you. But so we've got sort of the reasoning engine where we've got like RAG and the LLMs, and then the control plane, which are like the development platforms. And those can all work together to form assistants and apps and agents. So this is one of many references to Swix. I don't usually speak at the same event as Swix, and so forgive the references to it. But one of the things I really liked that he said was the software engineering lifecycle was make it work, make it right, make it fast. And the AI engineering lifecycle is make it work on one thing you want, make it generally work on most user queries, and then make it efficient. I think you can actually also adopt that in the enterprise AI space, where you make it work for one use case, you generalize it to other use cases or verticals, and then you make it efficient for other teams to build. So that's component one. Component two is repeatable accuracy. So as we know, LLMs are non-deterministic. You can put them together, you roll the dice, you get different output options. And that's something that we love to hate about LLMs. Enterprises also have this very large problem where their data is often really dense and specialized. So if you think, for example, of like a mobile phone carrier, a lot of their documents are going to all refer to like phones and SIM cards and cameras and things like that. And so it makes it very difficult to do things like sort of normal nearest neighbors searches and things like that, because the context is all kind of jumbled together. And we see this a lot with companies like finance companies, healthcare companies, that kind of thing. So there's a few different layers that we have tried to tackle this. We've looked at it at the prompt and code layer, at the RAG layer, and at the LLM layer. And I wanted to share some techniques for each of those. So at the prompt and code layer, we're really big proponents of tool calling. We just introduced a new model that uses tool calling, where you can make functions available to the LLM. And sort of at a high level, you're basically describing the functions in your code as a JSON schema, and then passing them into your call to your model as a tool. And then that model can can come back to you and tell you which arguments that you want to pass into that function, and you can execute it and get the response that you want. And now you can do a lot of great things like this because you're basically making any sort of API or anything like that available. Along with this, there are a lot of tools out there for structured output. So for example, one of the most popular libraries is called Instructor, where you can define some sort of model or schema and then have the model, the LLM, pass back to you a formatted response. So like in this example, you've got this user model, and then you can use Instructor to have the model respond in the format of that user model. And by the way, if that kind of thing is really interesting to you, the creator of Instructor, Jason Liu, and a whole bunch of other great researchers and applied engineers have this great resource called What We've Learned from a Year of Building with LLMs that I highly recommend you check out. There are lots of tips and tricks around building with LLMs. So then on the RAG layer, this is an area that we spent a lot of time on because most of our customers are dealing with like terabytes of data, and it's all very dense and specialized. So Graph RAG has been a lot in the news recently. We've actually been doing graph-based RAG for a number of years now. And we found that the graph structure really helps to preserve relationships between data. So highly recommend you check out graph-based RAG. But we also have found that that's not enough to get you to the level of accuracy and like less hallucinations that you need. So we've also done things like add in certain compression techniques that are context aware, and then we've applied some research like fusion and decoder to help minimize hallucinations. One of the papers that really influenced us is this one, Infusing Knowledge Graph in Fusion Decoder for Open Domain Question Answering. That's a mouthful, but that's a good one if you want to check that out. And we did a bunch of benchmarking on this where we've combined, like we use a specialized LLM to build a graph structure. We store it as a JSON object in a Postgres database. We apply things like retrieval-aware compression and fusion and decoder. And that has really skyrocketed our accuracy and lowered our hallucinations. So we've published some of that benchmarking. Definitely encourage you to check that out. And whatever we can do to like share that knowledge with the community and help everyone with their accuracy, the better. And then lastly, on the LLM layer, one of the things that we've really focused on lately is specialized domain-specific models. So these are models that are trained on industry-specific data. So you have more control over the information and reduced risk of leaking. And they take less computational storage, computational power and data storage since they're generally smaller. And then lastly, just because they're smaller and because they're focused, you can deploy solutions much faster. So two of the ones that we came out this year are our medical model and our finance model. These have open licenses. They're on Hugging Face. So if you're in those industries or interested in building in those, they're free for non-commercial use. So definitely check them out on Hugging Face and let us know what you think. We found them to be more accurate, faster, cheaper to run than general purpose models when used in those kinds of contexts. The other bit of research that we contributed this year was called Writing in the Margins. This was an inference pattern that enhances an LLM's ability to accurately interpret long prompts. So I've got the link to the paper there. But this is just an inference pattern. It's not really specific to our models or anything like that. You could do it with anything. So then the third component is rapid UI and UX, both for kind of prototyping and also getting into production. So we talked about how LLMs are non-deterministic, but somehow you still need to have good UI and UX at scale. So next Swick's reference is this is a well-known diagram of the shift right of generative AI for AI and ML engineers. And what's important here is that there's only 150,000 or so ML engineers in the world, but there's millions and millions of developers in the world. And so we're in this like interesting time where there's this difference in skill set between these different groups, and we're crossing these divides, both going from the ML side to the web side and from the web side into the ML side with AI engineering in between. Luckily, the market is building a lot of tools around this to help with building good UI and UX. So as a recovering web developer turned AI engineer myself, I wanted to share some of the best practices that we found for rapidly building good UI and UX in applications. So one is just to stick with tried and true technologies, things like web standards, really aligning as a team about what stack you're going to build on, whether that's Python all the way down or HTML and JavaScript. The next would be to make sure that you're separating your concerns and using some sort of state-driven UI. This can be done in multiple different frameworks and languages. As most things in AI right now, even though text is the kind of the universal programming language, we're seeing obviously a lot of multimodality, things like image and video and that kind of thing. And that's really changing the structure that we build UI and UX. Voice, for example, is a really big one. So considering that instead of just thinking sort of two-dimensionally with text and image. And then lastly, there are a number of new power tools out there. You've probably heard of a lot of them. If you're in sort of the JavaScript world, there's things like v0.dev and bolt.new, where you can basically put in a prompt, and these are basic, almost agentic systems that can build out your front ends for you. These UIs look suspiciously similar, and most of them have the same interface of basically putting in a chat prompt and building out a UI, but they're all really good. And there's things like cursor agents now and a replit agent. So front end is almost a solved problem at this point, where you can have a great model build that out for you. Python, not so easy these days. We have our own foray. It's not an agentic framework at this point, but we do have something called Writer framework that's free and open source that you're welcome to use. But basically, it's a drag and drop UI to build the front end and then Python in the back. And so check that out as well. It's great for data science applications and things like that. Okay, so quick recap. We talked about how AI can become a gravity well for enterprises. We talked about how we're seeing this increasing gap between more development projects versus fewer production projects and why that is. And then we talked about these three different components of enterprise AI escape velocity: scope, accuracy, and rapid UI. So we talked about the full stack approach and using microservices instead of monoliths. And basically enabling teams to, providing some pre-built solutions for teams and then providing tools that they can actually build themselves on. And then we talked about the three layers of improving accuracy, where we talked about function calling and structured output, graph-based RAG plus applied research like fusion and decoder, and specialized LLMs and writing in the margins. And then finally, for rapid UI and UX, using tried and true technologies, state-driven UI and separation of concerns, thinking in terms of multimodality, and taking advantage of all the new power tools that are out there. So lastly, Writer. I'm going to skip most of this, but we are hiring. We're looking for senior researchers and AI engineers all over the place. If you know anybody good, please send them our way. And thank you so much. Thanks, Alan. Thanks, everybody, for listening.
So conscientious. Thanks, Sam. Do you have a couple minutes for questions, if people have questions? We have a questions mic, and we have at least one hand up and a half-hearted hand also. So, we have multiple hands. So I'll give you back the mic.
Yeah, I just scampered off the stage. Sorry. Yeah, questions.
Hey, so how's it going? I'm Toby.
Hi, Toby.
And thank you for the presentation. Really awesome presentation.
Oh, thanks.
So we're talking about escaping exit velocity. How does an enterprise actually observe they've realized value from an AI initiative so that they can go from POC to larger scale?
I think it's often in terms of time saved and dollars saved. So, like I said, there's sort of using these point solutions of for example, if what we see often is one team will start to adopt some part of generative AI. Usually it's marketing first, because marketing is generating a lot of copy and analyzing a lot of images and things like that.
Wow. Okay. Great talk, by the way.
Thank you.
And you have one slide which presented that you want to built platforms and some pre-built stuff and some customization scope so that people can discover and make it their own, essentially. Now, what I'm seeing, a lot of enterprises just have this mad race towards building their own platforms. Everybody just wants to build a platform, but they might not have the right experience to do it. What's the path? Where do you start? Like if there's an enterprise or there's any company trying to start building a platform from their own, how do you go about it? How do you validate whether this is hitting the bill? And what's the first step?
Yeah, that's a large question. I think you've got to work backwards. I think trying not to over-engineer too quickly, probably. Start by building proofs of concept where you're using pre-built solutions for things and stringing those together in order to get to the result that you're wanting, and then kind of work backwards to if there's something that needs to be more bespoke or things like that, and then using evaluations along the way to check that you're getting the results that you want. I do think a bigger problem that often comes up is actually the problem is more in the data than the actual engineering. That's, I think, still the hardest problem in AI right now, and especially with these big enterprises. So I think the platform, over-indexing on exactly which steps to take on the platform, ends up being a red herring in a lot of scenarios where the problem is more in the data quality than it is in which combination of services and models and providers you end up putting together. That's my 2 cents.
All right, one last question.
Hi, do you mind going back a few slides to your full stack approach? I guess about 5 back. And my question is about this, and here's the context. I'm up to my eyeballs in this one. I'm up to my eyeballs in cybersecurity for AI right now. And you said this is what you're using for enterprise. I'm curious to know, in your experience, where have you put the controls for safety when you're building this for enterprise customers? Because that's a requirement, and the controls for safety and provability that your platform is not being abusive is a unique challenge when it comes to building these platforms. So do you put it below platform as a service, or are you ensuring it's built into pre-built apps on the AI Studio part?
Yeah, we put it in a few different spots. We have certainly at sort of the LLM layer, there's that part of it, but then we actually expose the guardrails too to make them customizable by the customer. There's actually a UI that you can toggle and customize them. So we have sort of our own layer of guardrails that is at the closer to the metal, and then another layer that's customizable to the customer that they can control which parts of the guardrails they want to add or subtract from. We have a trust, I think it's just writer.com/trust, that goes over sort of all the privacy and security that might be interesting to you. Sure. Cool. Well, thanks everybody.